Now in this lecture, we're going to be talk about how we can design the residential scale standalone type of an project. So whenever the battery is involving in the project, how to size the battery, then how we just design the panel connections. So everything that we can get from the PVC software. So whenever we design the residential scale standalone type of or off-grid type of an project, we'll have to click on this standalone over here. So whenever we are clicking on it, it will going to open the screen of the PVSyst. So now here we're going to be enter the project name. So project name we can give as per our requirement. So we just give the project number second. Then here we're going to be enter the site file and the Meteo file. So PVSyst is having the ready-made PVSyst databases there for the particular locations. If our location is not been there in the database, we can create the location and we can create the database for the particular location. For that purpose, we'll have to click on this particular choose site. When we are clicking on this choose site button, we just can able to see the various kinds of the city database has been given in the PVSyst. Let's say our site is not been there in the database, we'll have to click on this new button here. Whenever we click on this new button, it will going to open the map. Now we require the coordinates of the site where our site has been located, and we can import the data from the Meteo norm or PVGIS database. So for that purpose, we can just go to the Google map. We just open the Google map in the Google Earth software also. If we are having the Google Earth software, you can search the site name in the Google Earth. So just zoom on this particular site where we want to install the solar project and open this site into the Google map also. Rather, you can also just copy the coordinates of the site, just clicking or adding the place mark over here. Whenever you click on this place mark, you will find the latitude and longitude of the site over here. If you want, you can just copy from this also. Rather, this site detail we can just open into the Google map also online. So whenever we open the site in the Google map, so you will find the site will going to be load like this. So on this particular site, whenever we do the right click of the mouse, so you will find the coordinates over here. So do the right click on the particular site and we just copy the site location wherever we want to install the solar project. So once we have copied the site location, once again we go to the PVSyst software. Here in the locality, we're going to be enter the latitude and the longitude of the site, what we have copied. And then we're going to be just click on the search button. So it will going to be just focus where the coordinates of the site will be located, and it will going to be just show this particular site is been located on this particular portion. So now wherever the point has been located, that is a black point, that is our site. So we just accept this selected point by the PVSyst software and we just import this particular site parameters. Now whenever you see the parameters here, so you will find the latitude, longitude, altitude, time zone. You can just confirm whether this particular parameter is corrected as per the site location, and then we can just import this data into our database over here. So just click on the import. We can import the data from Meteonomate, NASA, then we have a PVGIS or NREL database or Solcast database. Whatever we feel which is the exact forecasting and the proper data has been recorded, so that from particular software we can import this data. So let's say I'm importing the data from the Meteo norm. We just click on this import. It will take 15 to 30 seconds to just download this particular data. It will going to download the global horizontal irradiance data. It will going to download the diffuse irradiance data. It will going to download the wind velocity, temperature and the turbidity, relative humidity, everything it will going to download actually. And this is a monthly data they have given. In January, when we see, it is a 143.6 kilowatt hour per meter square per month. It will be the data of this particular site where we are designing the project. When we see the global horizontal irradiance year to year variability, it is 5.7 they have just given us. So we can just take this data in terms of per month also, if you want in terms of the day also. So per day when you see, we'll find in the month of May, which is the summer season in the site, the data is very high, 7.01 kilowatt hour per meter square per day. This is the highest irradiation which is falling. And the average irradiation is 5.17 kilowatt hour per meter square per day. We'll keep the data in terms of the month only, and we just going to click on the OK button. We're going to be save it now in our database. So when we just click on the OK button, so it will going to be just asked to save the particular file. So here you can see the geographical site of this is now been created in the database. We just click on OK. It will going to ask us a synthetic hourly Meteo file has also been generated. Do you want to save it? So we just click on yes. So we're going to be save the site parameters, also the synthetic hourly database, that also will going to be see. And this is the file name, it will going to be saved, that mat parola 180 underscore syn, and we're just going to save it. Now you will going to be find the site location in the database also. Now you can see the site location has been saved in the database, and now we're going to be just click on OK. So this database will going to be import now as a Meteo file into this particular project database. Now further we're going to be just save this particular project. After saving the active project, we're going to be just see what are the other parameter that we can able to design it over here. So we just click on the save button, and now it is asking us please choose the plane orientation and the further parameters.